Okay, welcome to another BackNet recording. I'm going to call this one the Miscellaneous Blaster, or the Miscellaneous Grade B. This is just a few quick slides to take you through a few key topics for a Grade B. They're not really going to help if you don't understand what to start with. We'll need to record some other ones for that, but these are just to get it back in your head if you've done it once already. Okay, so first of all, standard index form. Right, 64000 in standard index form. Now in standard index form, you're allowed one digit before the decimal point, times 10 to the whatever it needs to be. So here I've got to have 6.4 times 10 to the, and I've got to think what this value up here is going to be, and my way of doing it is a little bunny. So, hop little bunny, hop hop hop, hop little bunny, don't you stop. My point's there, I've hopped it 1, 2, 3, 4 times. So that's 6.4 times 10 to the 4. I've got to make 6.4 bigger by 10 4 times to get the value 64000. Okay. This one. Write 156 times 10 to the minus 7 in standard index form. Now you may think it already is. The issue is, here we've got 3 digits before the decimal point. I need to move the decimal point to there, so it needs to be 1.56 times 10 to the something. Now, in making this part of my number smaller, I need to make this part of my number bigger to compensate. And bigger than minus 7 would be minus 6. So my step from 156 times 10 to the minus 7 would be to say, well, what about 15.6 times 10 to the minus 6? I've already made it 1 time smaller, so I can forget about one of the times there. Next stage is going to be 156 times 10 to the minus 5. So my final answer, there we go. I often find these questions where it's half given to are much more complicated than when you've got to start from scratch. Okay. If you want to have a go at these yourselves, press pause. Welcome back. Okay. This is some calculations using standard index form. The first one we've got is 6 times 10 to the 8 times by 4 times 10 to the 7. I'm going to split it down and do my digit bit there first of all. So 6 times 4 times by, now the other bit, 10 to the 8 times 10 to the 7. 6 times 4 is 24. 10 to the 8 times 10 to 7, we add indices, 10 to the 15. It looks like I'm there, but I'm not in standard index form. It's got to be 2.4 times. Well, I've made this smaller, so I'm going to have to increase the size of this one by 10. So 2.4 times 10 to the 16. Next question. Work out the value of 6 times 10 to the 8 plus 4 times 10 to the 7. There are proper ways of doing this, ways of lining it up, thinking about whether the difference there is only one value of 10, so that would be 0.4 if that was 6, etc. To be honest with you, in the exam, I'd take your time. 6. 1, 2, 3, 4, 5, 6, 7, 8. Now 4 is only going to have 10 zeros, so let's work backwards. 4 there is only going to have 7 zeros. 1, 2, 3, 4, 5, 6, 7. So that's a number I've got to add up. If I add that up, I'm going to get 64, 0, 0, 0, 0, 0, 0, 0, which is of course going to be 6.4 times 10 to the 8. Hop little bunny, hop hop hop, hop little bunny, don't you stop. 1, 2, 3, 4, 5, 6, 7, 8. Okay. New topic. I looked at this quick and thought this is going to be to do with density, volume and that, but actually it's not. It's one of my favourite topics because I think it's really straightforward. It's about limits, sometimes called bounds of measurement. The weight of the cube is 87 grams correct to the nearest gram. What is the minimum weight it could be? What is the maximum weight it could be? We're working to the nearest gram. We're told it's 87. I always get my students just to draw out a little part of a ruler. If you can imagine a ruler, you've got 87 there. You are counting in grams, so the next mark would be 88, 89. We're not doing it in 10 grams or 5 grams or 100 grams. The units we're measuring is to the nearest grams. So my ruler will go up in grams. It'll also go down in grams. 86, 85. And just having that picture in my head helps. What's the minimum it could be? Well, if the weight was actually about there, I would round it up to there. If it was here, I'd round it down to there. So the halfway point will be when I start saying, well, it can't be any less than that. And that halfway point is 86.5. Similarly, we have a halfway point here at 87.5. Anything above there we just said was 88. So the minimum it could have been would have been 86.5 grams, and the maximum it could have been would have been 87.5 grams. Now lots of students argue with me and say, well, that's not true, because if it was 87.5 we'd round that to 88. However, when we're doing this question we just know that it means it can be anything up to 87.5 but not actually including 87.5. You don't need to worry about that, just let it go. The examiner, that's the way the examiner is going to mark it, so just think of it like that. But the halfway marks on your ruler should be fairly straightforward to answer. Okay, factorizing. This means put into brackets. Factorize means put back into brackets. We've got an x squared term, an x term and a number term. That should tell me it's come from a double bracket expansion, or double brackets multiplied out. To get x squared, I'm going to need an x and an x. To get the 10 on the end, I either need 1 and 10 or 2 times 5. I've got to get a 7 by adding. Well, 1 and 10 is never going to get me to 7. 2 and 5 might get me to 7, so I know I need a 2 and a 5. Doesn't matter if I did 2 and 5, I could have done 2 and 5. Makes no difference. Now they're going to multiply to give me 10, but add to give me negative 7. So I need both of them to be negative. That's my answer. X minus 5, x minus 2. Part B. Solve x squared minus 7x plus 10 equals 0. I can rewrite that to be x minus 5, x minus 2 equals 0. I've got two brackets there. I've got bracket A and bracket B, and they're multiplied together to give me 0. If A was 0, whatever B was, the answer would be 0, because 0 times anything will give me 0. Similarly, anything times 0. Anything times 0 will also give me 0. So, whenever these two numbers are 0, I will get an answer of 0. They don't both have to be 0, just one of them will be 0, and I'll get 0. So, if A is x minus 5, how do I make x minus 5 equal to 0? What value does x have to take to make that bracket there equal to 0? Well, it'll have to be that x equals 5. Because 5 take 5 is 0. For this one here, how do I make that bracket equal to 0? Well, x minus 2 to be 0, x must be 2. 2 take 2 is 0. So the two values of x I can have to make this equal to 0 are x equals 5 and x equals 2. Hope that was useful to you, and I hope it's jerked a memory there somewhere. Okay, simultaneous equations. Again, there's a huge amount of work behind this topic. I'm just going to take you through it to refresh you quickly. I'm going to use a method of elimination. Some of you may have used a method that's called substitution, but these exam questions are set up for you to use the elimination method. I can't match here either of my variables, so I'm going to mess about and get them to both be 6x, because if it was 6x and 6x I could eliminate the x. So I'm going to times the top one by 2. That will give me 6x plus 4y equals 16. I'm going to change the colour of my pen and multiply the second one by a different number, and that number will need to be 3, so that the 2x becomes 6x as well. So I'm going to times that one by 3. 2 3s are 6. 15 so 6x plus 15y equals minus 6. I'm now going to work with those two to eliminate my x, and I'm just going to do the top one, subtract the bottom one. So I'm actually going to write a subtraction sign there and draw a line right across there and do the subtractions. 6 take 6 is 0. 4 minus 15 will be minus 11. Excuse me. 16 minus minus 6, now be careful there, minus minus, you're taking away a negative, so in fact you're increasing your value, will be plus 22. So minus 11y equals 22, so y will be equal to 22 divided by negative 11, which of course is negative 2. So I know that y equals negative 2. I'm now going to resubstitute the value of y into my first equation. So I've got 3x plus 2 times negative 2 equals 8. So 3x plus negative 4 is equal to 8. So 3x will be equal to 12. I'm subtracting 4, I need to add 4. So x will be equal to 4. So I think x equals 4. I'm now going to check both values in the second equation there that I haven't used yet. So I've got that 2x plus 5y equals minus 2. So 2 lots of the 4 plus 5 lots of minus 2 should equal minus 2 if I'm correct. 2 4s are 8. Minus 10 equals minus 2. It does. I know I've got that correct. Okay, there's quite a lot of work in there. I hope that's just jogged your memory as necessary. Okay, this is a cumulative frequency question. I've made it very large a minute so you can see what you're actually doing there. Lucy did a survey about the amounts of money spent by 120 men during their summer holidays. The cumulative frequency table gives some of the information about the amounts of money they spent. So 0 to 100 is 15. 0 to 150 is 25. So we're getting the running total as we increase going down. I'm just going to have to change that slightly so that I'm able to squeeze on the actual graph bit at the bottom. So I'm going to take that over to there, and hopefully if I scroll down a bit here I can pick up the graph as well. Okay, there we go. Let's just squeeze that a bit, and hopefully now we'll be able to see both, and we can just about, not quite, move it up a little bit more. We can just about, nope, still can't. Up a tiny bit more. Let's shrink this a tiny bit more as well. Right, now we're just about able to plot the graph as we need it. Okay, right. On the grid, draw a cumulative frequency diagram. So I've now got to plot this information on the cumulative frequency graph paper here. The cumulative frequency is up the side and the amount spent is in pounds. The crucial bit here is cumulative frequency. I often say to my students, cross out the first, by which I mean cross out that 0 there, and you're going to plot these points. So 100 against 13, 150 against 25, 200 against 42. I'm going to do that quickly now on this graph here. So we've got 100 against 13. I haven't brilliantly calibrated the board actually, it's moved a bit, so I'm going to really struggle to do this accurately. 100 against 13, 150 and 25 is about there. 200 and then 42, 242 should be about there. 250 and 64 is round about there. 300 and then 93, 93 is up to about there. I'm really struggling here, I'm sorry. 350 and then 110 is about there, and finally 400 and 120. That's my points done. I now want to try and draw those up in a smooth curve. Do not do a line with a ruler point to point. You need to try and draw a nice smooth curve that connects them all. I missed a little bit on this one here, but I'm not too worried about that. Okay, part A done. B. Use your cumulative frequency graph to estimate the median. Now the median is the middle value. I've got 120 people altogether, so the middle person will be the 60th. Now in the exam I want to get a ruler and draw that line across there to my line. and then get a ruler and draw down to see where I am. That was an awful drawing down there. I'll actually bother now to get up the straight line tool and draw that down properly. It should be from about there. There we go. And that's 240. So my answer there to that one is 240. A survey of the amounts of money spent by 200 women during a summer holidays gave a median of 205. Compare the amounts of money spent by women with the amounts by men. Well, the women, on average, spend less. Job done. Okay. Another question here. This is called the I call this the stem and leaf question. Again, it's quite a nice question because it is relatively straightforward. I'm just going to try and see if I can't shrink that down a little bit for us, so we can answer it as we go along. Let's shrink it down a tiny bit more. I also want to be able to there we go, read the information at the same time, which I've not managed to do there. So there we go. Nope, that's not good enough. It needs to come down a tiny bit more. That will do. Okay. Emma has 7 pens in a box. 5 of the pens are blue, 2 of the pens are red. So she's got 5 in the box. Sorry, 7 in the box, 5 red, 2 blues. Emma takes a random pen from the box and writes down its colour. Emma puts the pen back. That's really important. So this is a with replacement question. So there's always going to be 7 pens in your box. So when she takes it, she puts it back in. Then Emma takes a second pen from the box and writes its colour. Complete the probability tree diagram. Well, we know that there were 5 blues, so it's 5 out of the total of 7. That must mean there was only 2 of the red. She's put them back in, so there will still be 5 blues and a total of 7. There will still be 2 and 7. There will be 5 blues out of a total of 7 and 2 reds out of a total of 7. So I've completed that tree diagram. That's worth 1 mark. If we can't do any more than that, that's a really good start. B. Work out the probability that Emma takes exactly 1 pen of each colour from the box. So exactly 1 is either going to be a red and a blue, or a blue and a red. So I'm just going to highlight those 2 paths here on the tree diagram, and it was a blue, then a red, or a red, then a blue. So I want both of these 2 outcomes here. So the probability of that will be of a blue red is 5 over 7 times by 2 over 7. The probability of a red blue is 2 over 7 times by 5 over 7. That equals 10 over 49. That also equals 10 over 49. So you can have either this one or that one, so we're going to add those up. 10 over 49 plus 10 over 49 is going to be equal to 20 over 49. I don't want any 20s over 89. No, sorry, 98. The 49 is just telling you the size of the fraction. You've got 10 and another 10 of the same size fraction, so it would be 20 over 49. We can't simplify that. That's as far as we can get. Okay, that's the end of the miscellaneous blaster. Really rushed through a few topics there. This video was intended just to try and refresh your brain a little bit rather than teach you anything new. Again, I hope that's been useful to you. Do come back and watch another back of the net recording. Thank you.